In the last section, we spoke at great detail about the ampersand and star operators. The big takeaway was that if we have a value, we can turn that into a memory address by using ampersand value. And if we have an address or a pointer, we can turn that into a value with star address. And so that's exactly what we saw in our code base. We turned our variable that pointed at the struct Jim into a pointer or a memory address by using ampersand right here. And then we later turn that back into a value by using the star operator. The other very important thing to keep in mind, and again, this is one of the biggest hangups around pointers in Go, I think, is that whenever you see a star in front of a type, that means that we are looking for a type of pointer to a person. But if we see a star in front of an actual pointer, or an actual variable that holds a pointer, in this case, we interpret this as an operator that says, hey, I want to turn this pointer into an actual person value. Okay, so in this section, we're going to do one really quick thing. This is going to be a very short section. I want to point out one little thing around pointers that you're going to see very often in real Go code, and even in code that we write in the future as well. After we get through that, we'll then take a break and then come back and talk about one of the real big gotchas around Go. So let's get to it. Now, in the code that we have right now, you'll notice right here where we say ampersand Jim and then assign that to Jim pointer, and then only after that do we call Jim pointer.update name. Yeah, this is a real pain in the rear to write right here, right? Do we really want to write out this code every single time that we want to modify a struct? Well, probably not. So Go has a little bit of a shortcut that essentially does the exact same thing right here. So one thing before we look at this shortcut, I want to make one thing extremely clear. Remember, when we say ampersand Jim, that assigns a pointer to a person to the variable Jim pointer. So if I hover over this in VS Code, even VS Code says, yes, this is a pointer to a person, without a doubt, right? So when we create that update name function and we specify its receiver type as being pointer to person, these two things match up very nicely, right? Here's pointer to person, here's a receiver type of pointer to person. Yes, the two go together perfectly. They line up 100%. Now with that in mind, we're going to make a little change to our code that's going to look a little strange, but it's going to result in a lot less code being written in practice. So the first thing I'm going to do is I'm going to delete this line where we get the memory address of Jim, and then I'm going to change Jim pointer to be simply Jim. Now, I'll save the file. I'm going to go back over to my terminal, and I'll run main go again, and you'll notice that our code is still working. So I still have a first name of Jimmy right here. But now you'll notice that there is actually a mismatch in our receiver types. So right here, if I hover over Jim in VS Code, it says very clearly, 100%, no doubt about it whatsoever, Jim is a variable of type person. So Jim has a value of a struct. There's no memory address here, there's no pointer, nothing like that whatsoever, but somehow we are still able to make use of this function that has a receiver of a completely different type. Because this type is pointer to person, right? Pointer to person. This is just person. So this is a little bit of a shortcut with Go. With Go, if we define a receiver with a type of pointer to whatever, like pointer of blank, any type you can possibly imagine, when we attempt to call this function or we attempt to call this method right here, Go will allow us to either call this function with a pointer or with the core, the root type here, person in this case. Essentially, you know what, let's just look at the darn diagram. That's going to explain it better than I can. Okay, so here's the original code that we just had. Here's the change that we just made. And here's the function that we're working with. So at this point in time, iteration number 1 said, okay, Jim pointer is of type pointer to person. And then we had our receiver, which was pointer to person. So these two cases right here lined up perfectly. But Go allows us to take this shortcut and says, hey, if you have a variable that's just type of person, but then your receiver is pointer to person, that's totally fine. We'll just gloss over that fact for you, and Go will automatically turn your variable of type person into pointer person for you. So in other words, this is just a little bit of shortcut that we're going to use basically every single time that we use a receiver type right here of a receiver type of a pointer. So we do not have to actually coax the memory address out of Gym right here. Go is just going to kind of take care of it for us. Now, of course, if we went back to our code here and we changed pointer to person back to just person, well, now everything's going to break. Specifically, when we use this pointer right here, because now Go is going to say, oh, okay, person is of type person. No pointers here whatsoever. And so if we try to dereference this pointer to person thing with the star right here, well, now our code is going to break. So essentially, at the end of the day, what I'm trying to get at here, we have two options. We can either get the memory address from Gym and then use that as the receiver right here, or we can use just the value itself. Either way, it'll work fine with a pointer to our type. Now again, this might be one of those things where you're saying, Stephen, what the heck's the difference? What's the difference here? Well, again, this is one of those things where you're gonna have to write a little bit of code yourself and see a little bit of the stuff in exercises before I think it's really gonna sink in. So with that in mind, let's take a quick break. We're gonna continue in the next section, and I wanna point out one, that's not a pun by the way when I say point, I wanna point out one or two quick little things in Go that are real big gotchas around all this pointer stuff. So quick break, and I'll see you in just a minute.